Well, the day's finally come. The build's complete. We're ready to turn it on and take a look. And before we do that, I wanted to take a look at just kind of walking you through the cabling. So we went with a full Corsair environment for this. So all the LED control, fan control, everything's being done using Corsair iQ. So in order to do that, we have quite the wiring mess. So I wanted to show you guys what the wiring looks like. So first we'll show you what the wiring looks like before. As you can see, there's a lot of wires, a lot of cables, and it's kind of a mess. So when I initially put everything together, I just plugged everything in to make sure that all the electronic components are working, the fans are spinning, and the LEDs are lighting up. Then it's a matter of cable management. So how do we then get all these cables to fit inside of the system? So let's take a quick look at the cabling on the back, and I'll kind of walk you through what was done to plug it in. Then we'll power the system up, and we'll see what it looks like. So this is the back of the case. You can kind of see that there is a substantial amount of cabling on the right. There's some cabling over on the left as well. And this little panel that comes with the case is really quite good at hiding all the cables that are going from the power supply to all the other components. This is the cable mess required to control all the LEDs, fans, and everything else. Because there are so many LED components, what we've needed to do is we've actually used, you can kind of see them in the back here, there are two Corsair Commander Pros. There are two Corsair LED hubs right here. You can see the two Corsair LED hubs right here. So each of these controls 6 of the RGB fans, and each of the Commander Pros controls 6 of the actual fans and fan controls. So there's 2 Corsair Commander Pros and 2 LED nodes that come with the QL120 fans. There's also 2 of the Lian-Li controllers, one for each of the 24-pin controllers that we're using, the one that we converted into a 3x8 for the PCIe for the 3090. And then you've got just all of your cable mess. So, you know, you've got cable adapters to convert the Lian-Li cables and the ARGB cables into something that can plug into the Corsair Commander Pro. You can get these online, just converting them to the Corsair environment. So this is the cable nest. There's really not much else you can do short of cutting some of these cables shorter and repinning them. There's not much else you can do. Behind this panel as well, there are a substantial number of cables kind of hidden in the back that are all feeding into the front of the case as well. Now, of course, your goal is that you're not wanting to see those cables in the front. In the back, you can hide them, you can cover them up, but you want to make it so that the majority of cables are not visible from the front. And that's what we've tried to do. So you can kind of see that overall the cables in the front are mostly not visible. There are a couple of cables that we can see coming off the side here from the water temperature sensors that we're going to inevitably see some of those cables. But for the most part, we were able to hide most of the cables to make them so that they can't be seen either from the side or from the front. So without any further delays, let's power this thing on and see how it looks. Maybe I should plug it in. Maybe plugging it in would help. Let's plug it in. Okay, and plugged in. All right. All right, so with everything plugged in and ready to go, let's turn this thing on. there you have it. The build is finished. So let me know what you think about how it turned out in the comments. I personally think it turned out great. I love all of the customization of the colors. The Corsair IQ environment really lets me just customize everything. You can change every individual LED and program them to any kind of theme that you want. So it's actually fantastic, and I think it was worth the investment to get kind of the most peak performance out of the build as far as cooling, power, performance, as well as customization, color, and themes, because I'll always be able to change the color to any new theme that I want. So I'm very happy with how this turned out. But more importantly, it's not just about how it looks, it's also about how it performs. Now for benchmarks, I'm only going to be looking at this mostly stock, so we won't be overclocking today. I'm going to do a separate overclocking video, so stay tuned for that. But let's take a look at how this thing performs stock, and maybe with a little bit of performance boost override tuning on the AMD Ryzen 5950X. So let's talk a little bit about benchmarks. So for CPU temperatures and checking CPU performance, I was running Cinebench R23. I ran a couple of different tests. I ran it using Core Boost disabled. Core Boost is the standard default AMD algorithm that allows the CPU to boost above its base clock. So we've got a base clock of 3.4 gigahertz, and we disabled any core boost. So essentially, with all cores running at 3400 megahertz, we get a maximum Cinebench R23 score of just over 22,000. The maximum temperature during the test did not exceed 52 degrees. And the idle temperature of the CPU hovered around 35. We saw a maximum core voltage of about 1.031 volts with Core Boost disabled. With Core Boost enabled, which is the default setting for the Ryzen 9, you have a max all-core clock of 3824 megahertz and a max single-core clock boosting up to just shy of 5 gigahertz. Cinebench's R23 score was 24,812. Temperatures during those tests did not exceed 65 degrees Celsius. The maximum temperature achieved by the CPU was 71 degrees Celsius while running single-core workloads. The idle temperature on the CPU did not exceed 39 degrees Celsius. We do see some fluctuations in idle temperature, anywhere between 34 and 39 degrees, but for the most part it hovered around 39, so we took that as our measurement. The maximum core voltage is about 1.5 volts to the CPU, and that you will see when you're doing more single core workloads. When you get into the multi-core workloads where all cores are busy, that voltage drops significantly down closer to 1.2 volts. The maximum power draw that we got with Core Boost enabled was 129.65 watts. Now we took a little bit of a different approach. We took the performance boost override and we did a little bit of curve optimizing. So with a little bit of a tweak to the curve optimizer, we were able to squeeze out another 100 megahertz for 3824 megahertz max all-core clock, still hitting a single core clock of 4,999 megahertz, and we were able to achieve a Cinebench R23 score of 25,245. Again, the temperatures didn't get above 65 degrees during the R23 tests, and we still saw a max CPU temperature of 71 Celsius, and that makes sense because we're still using the same stock power outputs for the CPU of 129.65 watts. Now, the story changes a little bit when we get into the power limits. So when the power limits are maxed, when we basically set it to the motherboard limits, the power limits push the CPU to 4,374 megahertz all-core at about 1.212 volts. And we're still seeing a max single-core clock around that 5 gigahertz mark. This enabled a Cinebench R23 score of 28,392, and pushed temperatures to about 84 degrees Celsius. Idle temps remained pretty much the same, but we saw our power draw go from 130 watts to about 216. One of the cool things is that we didn't go above 84 degrees Celsius while running these tests. The Noctua D15, one of the best air coolers on the market, will still hit 90 degrees Celsius even under the best case scenario. So the cooling performance of the custom water loop is definitely performing extremely well, and I couldn't ask for more. With our CPU, we're using Arctic MX4 thermal compound, so we're only getting a thermal rating of about 8 watts per meter Kelvin, and so there are better thermal compounds on the market that we're going to have to try out to see if we can achieve better performance targets. Now, very quickly, we didn't want to get into too much overclocking in this video, so we just looked at the TimeSpy default run, and we got a score of 19,160. That was hitting a clock frequency of about 1,980 megahertz, average clock frequency about 1,848, and our memory clock frequency sitting at 1,219. Now, one really cool thing to note is that with the EK water block, we were able to maintain an average temperature of about 51 degrees Celsius, and during rigorous testing, we were unable to get the GPU above about 56 degrees Celsius. In a future video, we'll try pushing the graphics card and overclocking the CPU as far as we can possibly take it and see if we can defeat this base score that we've set. Well, now that the build's complete, we're going to move forward on future videos looking at how we can maximize the performance out of this system. So are there better ways we can cool the graphics card or the CPU to eke a little bit extra performance out of it? How far can we overclock it with this configuration to wring out every last little bit of performance? So we're going to be looking at every individual component in the system, how it performs. So thanks for tuning into my 2021 PC build series. I'm looking forward to doing future videos, future builds, and just talking about technology, gaming, and computer components. All right, so that's it for today's video. Thanks for watching. We'll catch you in the next one.